Welcome to the Securing Cloud IT Leaders are not aware or not in control of those applications from IT. So not only that they are using it, control over those cloud applications, but the enterprise is actually paying for them. Start a team and decide on a shared tool, then each team may have its own tools, cloud applications. It will almost always have average cost of not being able to meet compliance like GST, which can reach as high as $34 billion. It's the same tool on everybody, but minimizing the sanctioned applications. Those are the ones that you need a CASB. It's such a mandatory tool. Why isn't anybody all the endpoints you need to install agents on in it? You'll need to wait for a while for all the logs to be accessed and also for your employees training, and then you invest in a training program. Those are the reasons or being deployed as part of a SASE or SASE strategy. So users, whether they are remote or at the branch, a set of features added or part of the security significantly easier and far more accessible to many enterprises. Enterprises don't deploy CASB. In an SSC, zero planning is required because traffic is already routed through the SSC, depending on the vendor. That makes CASB as part of an SSC a far bigger scheme of things. It would take the traffic from remote and branch offices through different security inspection capabilities. ZTNA for on-prem applications and cloud data centers, next-gen firewall for east-west security, and so the goal is to make all those different components just one component. We do this by consolidation. This 25, which is not so far away, 80% of organizations are seeking to procure SSC-related security services will purchase a consolidated SSC solution rather than standalone CASB, Secure Web Gateway and ZTNA offering, which is up from a mere 15% in 2021. This is a huge shift from buying single isolated solutions into a consolidated cloud security offering. Another benefit of CASB that is part of SSC is the rich policy context. When, for example, user awareness provides user insights into the decision of whether to grant access to it because it provides a 60-degree coverage when the is growing. In a CASB, which is part of SASE or SSC, use the CASB that is simple to deploy and run, yet is powerful enough to protect your enterprise and
Hello, and thank you so much for participating in the SASE first ransomware. It didn't really take effect with greater than $3 million in profits in 100 days. And the list goes on and on, right? There came when bad actors figured out that they could make more money. They're fairly recent, except for the AIDS Trojan, right? So this is the very first attack we talked about. And you can see this, right? There's always this conversation around if you should pay the ransom and you shouldn't. A lot of times, these things that you're paying are fucking more and more. And if you've been hit with ransomware, you don't have to worry just about it's become a very big deal lately. In 2019, there was a new victim organization every 14 months. They can be very effective, and that bad actors look to make money. Applications is becoming more and more critical to business operations. Straightforward cost that is associated with a ransomware incident, and it's a smaller business versus large who give them the money that they want. Now they have built in some things to. It's not something that everyone thinks about or is even aware of, maybe. And that really includes your reputation, right, to customers. If are really just a term to it'll happen, countless times. But in this, the data to Mega. So if you're not familiar with Mega, it is kind of a consumer on the MITRE attack framework. So we can see this is, an attack by Revel, which aligns. They were the actors looking sign-in page. But with a couple of simple things, right? If we're using a secure web gateway, this is, in the next stage where they're trying to use Cobalt Strike, escalate privileges, and credentials like Kerberos tickets, things like that. And there are some legitimate uses by pen testers, some things like that. In this case, right, our anti-malware and next generation anti-malware engines. It's built with a partnership with SentinelOne, and we leverage their AI and machine learning. The WAN firewall. So we talk about zero trust principles. So that being said, we apply our zero trust principles here with our Cato accessing on the internet, websites, SaaS applications, all of these things. We also want to globally by blocking the things that OneDrive are more likely. And to be honest, right, those apps use CASB to say, okay, from our file sharing standard, OneDrive, you are more likely. And to be honest, right, those apps are broadly used and they're difficult to block outright because, just because my organization standardizes on OneDrive doesn't mean that I don't have users that interact with other companies that might have to download files from their box or their Dropbox or whatever that file sharing application may be. So this is where inline CASB really gives us some additional control, and we really get some more granular control here. If you look at the box screenshot on my slide, you can see that the upload of customer data failed. But that could be any file, right? In this case, we can use CASB. We've already addressed kind of the inline aspect, right? It's more simple to apply policies globally, and then there's MDR as a service. So MDR stands for Managed Detection and Risk Guidance on remediation, what they discovered, why I can deploy this and have full control over, security. Well, most of these tools are not very useful without TLS inspection, right? If we talk about TLS decryption, so now we have this huge stack of appliances doing everything that we manage, independent devices that share no context, have no correlates from the same vendor. You will still end up with multiple consoles, or you might have and firmware updates of our appliances. You have to do a hardware refresh every 3 to 5 years, only once. And it's not true. Attackers have to be right many times. We have very many opportunities. It's definitely better than non-integrated products that don't work together, but it's recertification. See you next time.
Hi everyone, and welcome to Vulnerability and how threat hunters and discuss some of the well-known ones. Then what was the root cause? So it's like this team walks around your house. These are from 2020, 2019, 2017, and every day they were vulnerable to compromise from exploits. So you can see here, patching is systems versus offline. If it's offline systems, so I did a very simple search. I did a search database. You can find it that scores these different. Essentially, virtual patching says, look, instead of can be a problem, of course, for IPS the disclosure to the time that there's a patch. So let's see how we're going up against the next big CVEs. And remember the notorious December 9th or 10th, depends where you are in the world, of 2020 logging tool for Java. You can celestial alignment of something that's, so this is the definition of a variable in Java, right? The dollar and the curly brackets. That's how you define a variable. Now, when you define a variable, so how do you counter that? Really quickly, and how they work. And if I understand how they use this one, we do is we assess the scope of the problem, we research it, we create, also had a lot of technical information, but Log4j is still out there. You still see companies that fall for ransom due to a Log4j vulnerabilities. Governments, all kinds of business in Ukraine, we still see usage of, in terms of how it's being handled. Of course, the exploit is very different. This is an exploit from 2021. So here's what you have to do. Read this, and do this, and then do this, and this, and don't forget this, and this, and this. You see how difficult it can be to patch a system. Kind of in the spotlight when it comes to cybersecurity. Not just Bergen, FTC warnings that companies, resources, and authorities to maximize the early detection of cyber and then sign and enforce it. Now, this actually patching. When you do threat intelligence, you really want to have information and handling from stuff that is reliable, so it doesn't cause vulnerabilities. And I had to take, of course, our example, right? Here are some critical for joining the SASE certification course. Enjoy it. Hi, and welcome to MITRE ATT&CK coverage with SASE, where we'll be discussing the MITRE solution, why it's such a prevalent, actually illustrates what it is that the default artifacts. So blacklisting IP addresses or signing malware, or create new hash values for and procedures. once you know how an attacker thinks and operates on real-world observation. So basically what MITRE, this is I believe the latest version. So what you're looking at here, it is with actually any report or database about how do you detect certain types of tools and techniques used by the attackers. Simulations themselves, there's a lot of information on the MITRE attack frame may be coming after us. How do we know which target for Iranian threat actors? Who want to get more information about APT33? Here's 33. These are the different techniques that they use. They use the software that they use. I see that they're using something called dark comment. It means that every time that the computer starts, this software details. You can deep dive and understand, okay, let's take a look at dark comment. We're looking at behaviors versus indicators, right? Yeah, it's not static, they also do. Let's continue. Here's a more, I'd say, deep. Google that link. I'm going to click on it, and you're going to see the MITRE attack navigator. This is what it looks like. It'll load in a second, and here we go. Here you can create these layers on top of the MITRE matrix, which is really, really interesting to do because it gives you a lot of different things. So here's a quick guide into how to use the navigator. I'm going to create a new layer. Enterprise, because we're doing this for enterprise. There are also MITRE attack from mobile and industrial control systems. We're going to do enterprise, and it's going to show me the MITRE matrix that we've seen before. Just here already, there's a lot of things that you can do. You can look at specific techniques and drill down. For example, let's say I'm interested in what is native API. I can right-click on it, and I can view the technique itself. So if I click on that, it will load that database that I've showed you before. So it gives you access into the database. But I want to do something a little bit different here. I want to take a look at two threat actor groups and understand, I'm assuming that they're going to target me. I want to see what are the most common techniques that they use, because that's where I want to start protecting. That's what I want to start looking at. So to do that, well, first thing, I'm going to search for these groups. So I'm going to write in here, say we talked about Iranian threat actor groups. You can see here are the threat actor groups. And I'm going to select APT33. So I select it. You can see it's somewhat highlighted, but in order to make it a little bit more visible, I'm going to add a color. I'm going to start by adding a score. I'm going to give it a score of 1. You'll see why in a second. And also, I want to play around with the colors. I'll say that my grid is not between 0 and 100, but between 1 and 3. This will make sense in a couple of minutes. So I created this new layer. Let's call it, I can change the layer name. Actually, I won't do it right now, but this is APT33. You can already see what are the different techniques that they use. This is already a great source of data. Let's add another layer. You can add another layer. In the same exact way, create a new layer. Enterprise. This time, instead of APT33, I'm going to add APT34, which I believe is oil rig. And there's a threat group here, oil rig. I'm going to select it. I'm going to give it a score of 2. I'm going to change the score coloring here as well, just so you see the difference. Now it'll start making sense. You can see that when I do it between 1 and 3, it's not red, but it's yellow. So it'll give me just a distinction. And what I'm going to do now is I'm going to layer the two of them one over the other. This is really interesting because it gives you all kinds of insights. So instead of creating a new layer, I'm going to create a layer from other layers. And it's going to be an enterprise. You can use older versions. I'm going to use the latest version. And all I'm going to say here is the score is going to be A plus B. Now you'll see how the colors make sense. And I'm going to click on create. And once I do that, you'll notice that I have 3 different colors. And now it's showing me what are the most used techniques by these two threat actors. If it has a green color and a score of 3, it means both threat actors use this technique. If it's yellow, it's only used by oil rig. If it's red, it's only used by APT33. So this is really good for me now as a defender because I can say, okay, if I'm expecting an attack from these threat actors, probably I first want to take a look into the greens because I know that they are the most common ones, or they're the ones that both of them use. So most likely there will be some evidence of those activity on my network. If you want to have a nicer look, you can probably do this type of sorting here. You can sort by alphabetic or by score, which gives you even a nicer view, puts the highest rating on top versus the lower ones. So really already a great tool in order to use to understand what we are up against. Okay, so this is the attack navigator. You can use it for many other things. All I did here was just layer two different layers, one on top of the other. Let's go back to our presentation, which is right here. It's showing the exact same thing that I did right now. And you can also do these layering, the different techniques that my organizations, my fictional organization, went a little bit to the east in terms of threat actors. And once I added the defenses as well, now you have this one that I showed you before. You can sort it through colors, alphabetical, and so on, used by the attackers. If you want to know a little bit more about what PowerShell, that actually provides you with a description of the attack based on the MITRE ATT&CK number, and then provides you the tools and scripts in order to run and test that. So they'll tell you, here's what you need to do, and here's a test. Run this on an endpoint, on the server, or whatever it is, and see if one of your systems raises an alert and says, we've detected some bad activity here. There are other tools that you can use as well, like Caldera. There's all kinds of adversary emulation plans. You can see some of them here, which are much more detailed. And really, it really depends on your appetite and your capability. But this can be used from anything from very high-level strategic kind of view into the threats and defenses, as well as a very deep dive into the very specific tests that you need to run in order to detect these, or emulate, I should say, these attacks. The third and final portion of an approach in order to actually detect threats. Actually, if anything, the reverse is. And a lot of times when you read about it in the news, you are already here. As they say, oh, just click on finding yourself at the final, impact stage of the attack. You really want to be everywhere. You want to have you'll find it in the management console. You'll see reporting about the number of times that we've seen Cloud Engine. Why? After that, you'll be able to, to enforce the policy, right? Okay, doing this with point solutions is not really. So now you can see why SASE solution does. Thank you for joining this session.
Hello again, and thank you for participating in the Advanced Security track of the Cato SASE Expert Level 3 certification. Really excited to go through this session with you. In this one, we're going to talk about testing your SASE security and visibility. Now, let me hop over to my MacBook Pro here really quick and just give you an idea of what we're doing. So here we have an in-house tool that we use for quick testing and to generate some data in our environment. Now this tool is only internally available at Cato, so I can't tell you much more about it or give it to you, but we'll run a couple tests here. So first, let's start off. I'm connected to a network that is not passing through Cato, and I'll go ahead and run the test. So as you see, everything is successful. There's a couple of errors here, but this is only testing, so it doesn't really matter too much. But the point is that a lot of stuff will get through. So let me go ahead and change, and I'm going to connect to a wireless network that is passing through Cato via one of our socket devices. So now that I'm connected, you can see we're connected to Cato here. Let me go ahead and run this test again. And just like that, just by connecting to Cato, we're blocking all of these threats and all of these bad activities. So let's try one more thing. I'm going to go ahead and disconnect from the Cato network back to the regular network, but connect via the Cato SDP client. So now we're back in the regular network. Let's go ahead and connect this client and run this test. And just like that, still everything is blocked as expected, despite being on the mobile client. So, like anything cloud, it takes a couple of minutes for this information to appear in our logging. So let's grab a cup of coffee and we'll be right back. Here we are, we're back. This is the Cato management application. Like any good SASE solution, it should really have a single cloud-native management application. You shouldn't have to be linked to disparate management web consoles that do different things and have different information with different backend architectures, as well as separate logging and storage. You should really have a single converged management application that's cloud-native. You shouldn't have to download and install anything, install plugins, make sure your plugins are the right version. None of those pains. You should really just be able to access this and manage your entire deployment from one single place, all with a correlated backend. Now, if you think about what we did earlier, right? And it's been, a while, I'll say, but it doesn't have to be, right? Logs typically appear, 2 to 5 minutes in the portal. It's not a long time before that information is available to you, but practically I didn't have a chance to get back into it until just now. Now, if we talk about our legacy deployments and what things used to look like, we had to rely on, separate types of products and appliances and different things like that are all collecting their own log information and logging their own attributes related to every event. Now, to deal with this, we would purchase and install additional systems, only adding to complexity, like SIM and SOAR, to take that information and make it usable to us as practitioners. Now, that was great. It works pretty well, but it also introduces some areas where things can go wrong. It makes it more challenging to correlate your activity. You have to rely on ensuring that information is flowing properly and that everything is configured in your tool as you expect to let you know and bring attention to the things that matter. And this isn't always the easiest case, especially as deployments age and you get further and further into adopting new and other technologies. And we often relied on having kind of a centralized data lake to dump all of this information and then pull that into our other tool, right? So maybe we have, multiple firewalls, some proxies, some sandboxes, some other different types of appliances, and we would stand up our own data lake or purchase one from a vendor. We could also, build it in AWS or something like that. And then we're going to pull it into our tools, create some policies and rules to alert us around different types of activities, but we're really not achieving the correlation level that we need to. Now, one of the brilliant things with SASE is that ideally your SASE vendor should be processing security and networking from a converged architecture. In the case of Cato, it's our single pass cloud engine, which is our true single engine that does all of the things that Cato offers you. And because of this, it's all unified architecture. All of the logging information is stored consistently on the back end, automatically correlated, as well as sharing context between all of the security engines. So we'll get into that here a little bit more, but let's jump over to our threats dashboard and take a look at what we have. So this is our threats dashboard. By default, we're on a 2-day view, but you can easily come up here and filter, based on whatever you want from these predefined timeframes, or set a custom range. More easily, we can take a look at our threats timeline here. So we see that there was some activity a few days ago, and then we see some activity today, which was a nice spike in threats. So based on that, maybe we want to investigate the most recent, and we'll click here, click and zoom, and there we go. And now we're zoomed in specifically on October 19th from 12 to 2:53. So this is exactly when these spike in threats occurred, and we get some really nice information here around what is happening, right? We see, all the top threats in that timeline. Obviously we see our timeline and we can zoom out and move as we like. And we also see that all these threats are coming from Ireland. So what's interesting here is, maybe you have a very simple way to improve your security posture around geo-restriction. SASE makes geo-restriction extremely easy because it's all a single platform, and it all controls, your entire volume of traffic is ideally passing through the SASE service. So in this case, Ireland might be a little bit more challenging to block based on being a country that you might actually interact with from a website, SaaS, and cloud perspective. But let's say it's a country like North Korea, Russia, Iran, one of these countries that you really probably don't need to access resources into. You might, and you could configure specific exceptions for those resources, but overall you can block, all traffic to and from that country and enjoy a better security posture with very little effort. Now, if we look down on the page a little bit more, we can see a breakdown of our different types of threats for our different security engines. In the case of the top one, we're looking at IPS specifically, and here we see our 48 threats. 30 of them were web application attacks. Then we have some malware, remote code execution, and so on. But we also see our top hosts and users that were subjected to these threats. So if you remember the test that we ran earlier, we ran from both a Cato secured network via the machine, and then we use the same machine to connect to the Cato SDP client. So that's why we're seeing the same host here as well as the same user. Now, going down a little bit more, we have our anti-malware engine, which is taking a look at files and scanning them for malicious tendencies or signatures or whatever the case may be. In this case, we have one file name here. It's a very non-indicative file name. It's could be anything, to be honest, but we detect it as a threat, so it's logged here, and then we see the same users and hosts. Now, this may not be super compelling given this is a lab environment, right? There's not a lot of information to see here, but think about this within the context of having thousands of users and hundreds of sites deployed, all the types of information that you'll see here, and the quick access to visibility across the board of all threats that are happening. Now, let's say we want to do an investigation or look into some of these things a little bit further. We can easily go up here, click on our little hamburger menu for Log4j remote code execution, and we can add to a filter. So what this filter does is it takes this entire dashboard and centers it just around this information. And your filters don't have to specifically be top threats. They could be really, a variety of information. You could look for all threats that are being, logged for a specific user or a specific site, or coming from a specific IP. Whatever it is that you need to look for, you can filter this dashboard based on that context. Now, once again, right, not super exciting. We only have one user and one host that have experienced this threat in the timeline that we specified. But imagine if you have, way more users and you need to know where to look to strengthen your security posture. Easy enough to do here. You can definitely do that. Now, let's go ahead and to do another thing. If you click on your hamburger menu again, we can actually click View Events. And if you see here, we're still filtered in on our very specific October 19th, 12 to 253 range, but we're looking at the event discovery window. So Cato's event discovery window provides you with access and easy correlation and filtering of all events logged by the Cato SASE cloud. Now, we're focusing very specifically on security in this conversation, but beyond that, we're also logging things like networking activity, access, when sites are going up or down, when users are connecting to their SDP client. All this information is stored here in the same logging infrastructure with the same context and the same data points as everything else. And that being said, Cato stores logs for 6 months at no charge for our customers. There are other options available, and you can easily export this information to a SIM, SOAR, or whatever tool of your choice via our APIs. So really the flexibility is yours, but we do give you a way to easily look through your information, find the data that you need, and identify and investigate threats without having to rely on the complexity of third-party tools. So that being said, let's go ahead and take a look at one of these entries. We'll expand the very top one, which is the most recent, given the filters that are applied. And if we scroll down, we can see a couple of things here, right? We can see that we definitely blocked this threat. As we know, it came from, Ireland was the destination country. We can see the IP address, and we can also see the domain name, port, protocol, which security engine caught the threat, all of that. Now, if we look at the domain name being reflector.peterjames.org, it's kind of interesting. Maybe it's not something known to us. Maybe we should look into that a little bit further. And maybe it's something that we could just block the domain altogether. We have no legitimate reason for it being allowed on our systems. Even further down, right, we see some really nice activity that helps us align this to, a more broader attack, right? So we're alignment to the MITRE attack framework. So here we can see the different subtechniques, tactics, and techniques that we're aligning to based on, what we detected in this attack, the very specific signature ID, as well as the user and source of this activity. Now we can see the threat name, and we can even see NIST information from, the government, on this CVE reference, giving us even further context on what's happening. Now, if you remember from the test that we did earlier, we did it from a machine that was not connected via the client. It was connected via a secured Cato network behind one of our socket devices, as well as connected to the client. In this case, since the client tests were towards the end, the most recent one was from our SDP client connection. But maybe we don't want to look at that right now. Maybe we'll want to specifically look at just things that came from the site level when it was behind that secured network. So that's very easy to do. As you can see, we have a ton of fields here. You can quickly look through and add filters. But in this case, let's go ahead and do a search, right? We're going to put source. And here we have some nice options, right? We can see, filter on source country, source IP, whatever that is. But in this case, we want to identify whether the source is a site or an SDP user. So here we can see that we have 4 events for sites, 2 for SDP users. And in this case, we're going to go ahead and add the site filter right here. So now we're down to just 4 very specific events that fit our filtering specifications. And we can go ahead and expand one of these again and take a look, right? So as you can see, very, very similar, exact same context that we had before with our remote user. So really no other, no different information. We have all the same information. It's very easily to correlate. And not only that, all this context is being shared across Cato security engines. And this kind of gives me a nice segue into a story that I like to talk about very often. I speak with a lot of customers around different security things and how Cato can help them. But more importantly, I get a great understanding for things that they're experiencing in the real world. So a lot of our customers, a lot of prospects that come to us have experienced ransomware incidents in the past. And not for lack of, trying to have a form of protection. They have, all the standard tools in place, next generation firewalls, proxies, maybe even sandboxing, phishing protection, endpoint protection, SIM. They have all of these tools that they've made investments in. The main problem, though, is going back to what we talked about with the legacy approach, and then you have to take all separate information that has separate types of context, separate fields, and try and correlate that via some pre-configuration that you did. And a lot of times this results in the attack not being detected until the very end stage when data is encrypted. Now at that point, the impact has been done. Data has been encrypted across multiple systems. The attacker has been in there for several days or weeks and really done maybe more than you even realize. Exfiltrated your data, mapped out your environment, and now selling that to other bad actors. So it's a problem. Now, if you look at a really strong converged SASE platform, a really good SASE platform should converge networking and security fully. So in this case, we're using Cato's single pass cloud engine, which is truly a single pass engine that performs networking, security, and remote access components with minimal impact on performance. But beyond that, it allows correlation and shared context between all of the different security engines. So if you look at some kind of behavior that's suspicious, on its own, it might not be enough information to determine that something bad is happening. So with shared context, we can look at the broader picture, right? We can see what countries are being used as the destination. We can see what types of applications are trying to be used, what's trying to be downloaded, who's doing it, what they're trying to do. And all this information can be correlated automatically by the system to create much stronger verdicts regarding things that are happening, good or bad. And beyond that, it gives you an easy way to investigate and look into the activities in your environment, all from a single place. And that's not to be said that you might not want to use a SIM or a SOAR tool. They definitely have value. But it's very easy to come in here, conduct your own investigations, understand what's happening in your environment and with your deployment without relying entirely on these third-party tools. So, like anything, the best combination of multiple approaches will typically yield you the best results. We want to, address defense in depth, not just from a tool and appliance perspective, but from a practical perspective where we look at what's happening in our environment. Now, if you think about what we talked about, SASE and SSE architecture matters significantly. If you're relying on a SASE or SSE vendor that has taken, separate products, integrated them together, and is, launching that as their SASE or SSE platform, you may still have some of the same issues that you had with the legacy deployments, especially around sharing context, remediation, and investigation, where it's difficult to correlate these different activities because they're all from disparate systems. And even if they're in one place, you have to manually configure some rules to process that information, display it to you how you want, and ideally alert you when something is wrong. And even more importantly, ZTNA can limit these problems, but when you get into east-west traffic, you have often reduced visibility with legacy deployments and with SASE deployments that are not fully converged in cloud native, and it really makes it challenging for you to conduct investigation and detect attacks early enough to prevent them or to minimize the damage rather than detecting them once all the bad things have already been done. So that being said, we discussed this a bit. It doesn't matter what the source is or how your user is connected. They can be through an IPsec tunnel. It can be a cloud resource that you're protecting behind a Cato V socket. They can be behind a Cato socket connected to our cloud at one of your sites, or they can be at the airport, Starbucks, or home connected to the Cato SDP client. You get the same level of consistent visibility and correlation of all of that activity in one single place. And you can easily and quickly filter this based on whatever information you're looking for. So once again, thank you for joining us for this session on visibility and testing your SASE security platform. I hope you're enjoying our Level 3 SASE Expert certification, and I'll see you next time.
Yeah.